Going to be the topic of today's webinar. My name is Ron Hicks. I'm a managing partner here at Valenture, and I want to thank you for joining us. Let's jump right into it. A common sense approach to security. We're going to be looking at the top 6 priorities that it takes to create a full fence of security around your business. Just like the example of a fence in a backyard, it doesn't make any sense to create half a fence and half of it be open, right? So that common sense approach is what we're going to be using. Now, behind each of these 6 priorities, these 3 principles are going to be our guideline. First, wisdom from the field. Let's look at what's going on in the real world. How are real cybersecurity events happening, and how can you really protect from them? So these top 6 priorities are based on real security events in today's cyber environment. Secondly, a guiding principle is going to be good enough is good enough. You don't have to be first. You just don't want to be last. Like our graphic here with our friend the gazelle rocking out the wheelie here on the Gixxer. It's a common sense approach. When you're operating in a hostile environment, you don't have to be first. You just don't want to be last. And thirdly, don't break the bank. Get the most you can, the best bang for the buck. Leverage your existing investment, keep it vendor agnostic, and make sure that you've got a full fence built. Not spend too much, making too thick, too high a fence in some areas while leaving other areas completely undone. So here we go to our top 6. Number 1, the first. Actually, let me set the background a little bit here on the network design that is a prerequisite or an assumed position that we start from. We're looking at a hybrid network design here. Now, what's the hallmarks to a hybrid network design? Most clients are going to have a network that's going to look very similar to this in some fashion, kind of simplified, but they're going to have a data center with servers on site or either in a colo facility that they own or lease and so forth. They're going to have local users. This would be like a headquarters with the data center inside with a redundant internet edge, probably dual home BGP and so forth. They're also going to have remote users that more than likely are going to be VPNing in for access to local resources. They're also going to have remote sites. These remote sites are going to be connected normally via an MPLS or a site-to-site WAN. In addition to local resources, many clients have some form of cloud initiative going these days, right? Either from a SaaS service like Office 365 or so forth, or a cloud data center like Azure or AWS. So that's the hallmark of a hybrid network design. Resources are local data center and in the cloud, multiple places to go to resources, and also multiple sources going to those destinations like your users are everywhere, local and remote. So that's our basic topology that we're going to be working off of today. Number 1, our biggest recommendation is human eyes on glass. We all have invested in equipment already. We've invested in firewalls and maybe endpoint agents and servers that are kicking out logs and SaaS applications that are kicking out logs. All of these logs essentially become an alert cannon, creating a lot of fatigue for anyone trying to look through these logs and figure out what's important and what's not. So the biggest thing that we recommend is getting some help there. Real eyes on glass, real people, and real responses to events. We call that managed NSOC 24/7, 365. I think Marcus at TrueSec said it best at a recent engagement with one of our clients. He said it this way: our strongest recommendation is to use a SOC that offers 24/7 monitoring. There are too many hours a day and over weekends and holidays when threat actors are active and you're asleep or away. So using active monitoring is a must-have in today's world to stay safe. I agree completely. Managed SOC, powered by Overwatch. We're going to be talking about different solutions that we recommend today, things that we know work and that we prefer. Overwatch is one of those. It's a service that monitors, detects, and responds to security threats. Basically, it's 24/7, 365 security incident response. It includes a user portal that you'll have access to, the SOC engineers have access to. Auto ticket generation, so that when there's an event, there'll be a ticket generated automatically, as well as customized run book, so that it's a co-managed approach. Some things you'll take care of in-house, some things need to be outsourced and can be taken care of that way. Plan that out in a customized run book. On the SOC side, that's the same exact thing on the NOC side, other than it's a network. It's a network operations center instead of a security operations center. So it's going to provide visibility and alerting into your network device monitoring. Again, 24/7, 365 response, user portal, auto ticket generation, and customized run books. Now, I want to pause just a second before I go too deeply into our managed NSOC and mention a couple of things that are optional, but are pretty important. Again, remember the principles. We're talking about what's going on in the real world, right? We want to be somewhere we're not the slowest, but not the fastest either. And we want to be smart about not breaking the bank and how we're putting things together. These optional components directly deal with things that are going on in the real world. The first, dark web monitoring. This makes sure that if a user in your environment already has credentials for sale on the dark web, that you'll know about that. This service provides next day alerts for dark web credential compromises. Daily dark web monitoring for all business email addresses, and it includes a user portal. The second optional goes really closely with this. A lot of security events happen because someone gets an email, they click on a phishing link in the email, and the security event happens as a direct result of that. So in line with that, we recommend some kind of security and email phishing training. We like Bullfish. It goes right along with the dark web monitoring as a package here, and it provides you real security training. So you set it up; it's a year subscription. It sends out random email messages that look like phishing attacks but aren't. When the user clicks on them, it lets them know, hey, you shouldn't have clicked on that, and it lets you know as well who's clicking on these emails. So in case they need to have more training, you can accommodate that. The third optional one is device updates. And for those of us who run security scans, we know the results, right? It's going to come back with your critical, your updates, your revision, your code revisions need updating, software on firewall, software on servers, and so forth. So this is a service that just takes some of that working load off of your internal folks and can keep things updated, either through a manual process or really through an automated process. We like AutoMox, and I'll talk a little bit more about that with this. The fourth one is a 50-hour block of hours, and this makes sense for a lot of reasons. Instead of buying an all-you-can-eat service, nobody knows the future, right? How much is going to be needed in this type thing. What you do is you purchase only the services that you know you're going to use. The correct tool to monitor all of these logs and throw things in there to get information out of it, and a real eyes on glass security professional to watch these. But anytime you need to escalate things up to, beyond just the normal, then you can pull from this retainer block of hours for anything that you need to engage us with. So this combination of not an all you can eat, but buying only what you know you need and having a block of hours sitting here as a retainer so that you can control that spend, that's what we recommend. So let's look specifically at this portal that you would get with the SOC service. It's based on a MITRE ATT&CK framework. The tool itself is AI, artificial intelligence, and it's anomaly based. Like security in the real world, it works, right? Everything's normal until it's not. There's an anomaly happens, and then there's an alert off of that. That's the best way to do security. So in line with that, let me show you how this thing's going to work. Take all your logs, you throw it in here, all your firewall logs, server logs, SaaS logs, and so forth. The system will, as events happen in real time, it's going to create a threat score for each event, and that threat score is going to go up as it walks down this MITRE framework. Let me give you an example. There's an attacker, and they're scanning at the front door of the internet. We're seeing scanning and initial attempts. That's going to be where the event starts, right? That's going to have one score. Well, as the attacker has a persistent foothold in the environment, now they've got into the environment, then that's going to greatly add to the threat score. So that threat score is going to climb. As explorations going on in the environment where the attacker's trying to find what's going on and stuff, again, when we see that, it's going to come up with the threat even higher. And propagation, this is where there's actual software put on your network and things like that. That's going to raise the score even higher. And lastly, exfiltration, and this is where we certainly want to catch this before it happens. This is where the attacker is actually trying to get treasures out of the company, or ransomware attack, lock up servers, and so forth. So the idea here, the reason this is our number one recommendation is this is time sensitive. The time to detect and the time to respond has a lot to do with how far that attacker is going to get in the network and start to do bad things. So that's our number one recommendation and how this works. So let's put this on our diagram here. So these are the top 6 priorities. Number 1, managed NSOC 24/7, 365. Sits here. Again, NOC SOC, co-managed services based on a run book. A little bit of the details, as you can see, part of this service is a physical appliance at each remote site, at each of your sites, maybe a headquarters site, maybe a remote site. This photon is what it's called. It's going to be where you kick out your firewall logs and other logs to this device on site. It's going to compress those logs and send them up to the SOC. This helps because it cuts down on the ingestion, which a lot of the cost is driven by ingestion. The other things are, you're going to, as I mentioned, you're going to have logs coming out of your SaaS here in the SOC. You're going to have logs coming from remote sites into a photon on that site, bringing that into the SOC. We're going to have endpoint agents more than likely running, feeding those logs in, as well as servers feeding logs in. So all logs go into one place. Artificial intelligence, letting the computers do what they do best, right? Anomaly-based detection. And once that threat score climbs, a real person steps in and acts on your behalf based on the run book and what's agreed upon ahead of time. Moving on to number 2 in our top 6 priorities. It's going to be backups. Anyone that's been involved in a real cybersecurity event knows that immediately the first thing you do is, okay, let's go look at the backups. Let's get those backups and get restored and get back up. The real world, though, a lot of times that's exactly the jewels that attacker, bad actor, is looking to find first. They're going to find those backups and destroy those backups so that the ransomware has some teeth, right? There's no way to get back and quickly restore, or else who would pay the ransom? So this is one of the biggest targets for bad actors. Now, what are we looking for in a backup? Simply put, we're looking for them to be immutable and air gapped. And what I mean by immutable, an immutable backup is where the data is secured in that it makes it fixed and unchangeable. Once the backup is done, it can't be deleted. It can't be changed in any way. So it protects from accidental or intentional deletion, and especially in a ransomware attack situation. The Datto Sirius line, we're pretty big fans of them, primarily because the backup, once the backup is done, the system scans the backup to make sure that it's not a bad backup and already has ransomware. So the backups are scanned for ransomware, which is a key component. Also, the backups are stored on the cloud in an immutable, there is an immutable backup stored in the cloud, so that the snapshots there can't be corrupted by ransomware. The third reason we really like the product is it has an on-site appliance component, so that as the backups are done, that's placed out in the cloud. But in addition to that, if you lose a VM or a hardware goes down and you need to spin that VM up on the backup appliance, you can do that and have the actual backup appliance replace a failed server. So spin the VM up on the backup appliance, run off it while you get the server replaced, and then roll it back. So we like that. The Datto SaaS protection is also pretty cool. A lot of folks are using Microsoft 365 these days, and it's specifically geared toward that. Doing advanced threat protection in a 365 environment, as well as actually scanning that environment up to 3 times a day. Now, air gap backups, what are we talking about? So this is a backup to the backup. The idea here is we back up like we normally would. We put it in the cloud like you'd expect an immutable backup. But let's say worst case scenario, something happens, those backups are not good. What this is either a tape drive or a removable hard drive that's done periodically as it makes sense in your environment. But once you do that backup, you pull it off the network. That can be done several different ways. As I mentioned, maybe just an old school tape drive. Maybe it's a removable hard drive. Maybe it's a server that's built with quite a bit of disk space so that it's on the network, so we can do we can move the backups over, but then we disconnect the switch port to make sure that it's off the network and no bad actor that has network connectivity can ever see it or get to it. So that's what we're talking about with backups. Nothing much sexy on backups, man. They really are important. So they're number 2. Let's put them on our diagram here. So here we are on our diagram. Top 6 priorities. Number 1, managed NSOC. Number 2, immutable and air-gapped backups. Immutable out here in the cloud, air-gapped backups local. Number 3. Number 3 is about controlling east-west movement within your company. We're talking about hardening the network so that there's not just a firewall at the edge between you and the internet, but actually there's some firewalling services that are blocking off different parts of your network. Microsegmentation is often called. So the piece of hardening the network here is going to be network segmentation as well as a secure design. We'll talk about this a little bit more in a second. The second thing is hardening user identity and authentication. As we mentioned, a very high probability that when there's a security event, it's going to have a user authentication component. It's going to be around a user that's compromised. So in order to shield ourselves from real world events, we want to harden the network, and we also want to harden this user identity and authentication. And the third thing here is a secure management access, an out-of-band management, we call it. The idea here is to, if there's any kind of management required of network devices, servers, and so forth, there's a completely separate VLAN set up for that with a completely separate entrance into that VLAN so that management does not happen in the production network. So as we do these network segmentation projects, separating out this user can get to that server, or this app can get users use this app, and so forth. If we take management off of the production side of the network before we do network segmentation, it just makes the network segmentation project a lot easier to accomplish. There's less caveats to deal with. So diving a little bit deeper here, network segmentation. This creates internal network security to protect assets both north, south, and east, west. Essentially, what it does is it replaces your core routing at layer 3 on that site with a firewall rather than a core switch. Most environments now are legacy in that they're designed any connectivity inside with firewalls at the edge, and that's where we provide security. This is essentially moving the security to the correct place inside the company, meaning between users and servers, maybe between servers and IoT devices, or wireless and servers, and so forth, so that the firewall takes the place of the core switch. It becomes the default gateway for the VLAN, literally. We'll look at that in a picture here in just a little bit. Moving on to the hardening authentication. I'm sure you guys are doing multi-factor authentication. If you're not doing multi-factor authentication now, you most certainly are the slowest gazelle out there. So please make sure we at least get multi-factor authentication in place. But there's a lot of other things we can do. And this has to do with, again, leveraging your existing investment. You already own Active Directory. Why not set that Active Directory up in a tiered fashion so that it has those same controls like we're talking about on the network side? That's called AD tiering. Why not get rid of admin passwords on your local machines, where if there is a compromised user that gains access to this workstation, there's not the domain admin credentials there. That's what LAPS is about, providing random passwords for common local admin account on every computer in the domain. And as we roll out this hardening of authentication, naturally there's going to be roles and responsibilities in place, right? You're going to have your user account that you log into your workstation with, but if you need to log into a domain controller, that's a completely separate user. That's a completely separate user with those roles and responsibilities controlled. So as the proliferation of different user accounts and passwords and those type things are put into environment, it can make it kind of cumbersome, difficult to deal with. So for that reason, we recommend an enterprise password manager. It's a very nice thing to have. We like Keeper for this position. It basically protects and manages and shares your organization's passwords. So we don't have to write them on anything. We don't have to send them an email. We basically put everything in this digital lockbox, this, if you will, where everything is housed. And then we have credentials that we hand out and we share certain records. So for the administrative staff, possibly in the IT team, there will be a rule. There will be an entry in Keeper for the domain administrator information, the password, the user, and the password. And so if someone needed to do maintenance on that domain controller, then they would go to password manager, they would get the information out of there, and then they would log in with that separate user account. So hardening user identity. I already mentioned a little bit about secure management here out of band. Let me show you a little bit of what network the AD tiering looks like here. And we get quite a bit of questions about this, and I think this is an excellent diagram here that shows it. This is I found this out here. There's a link to this. You guys can Google this, Petri IT Knowledge Base. It'll tell you why you should use AD and a little bit more details on it. But at a high level, it simply provides 3 tiers. Tier 0 is the most secure tier, and this is where you put your domain controllers. Tier 1 is also more secure than tier 2. This is where you put your normal servers, and tier 2 would be where you put all your workstations. The idea here is there's credentials for tier 2 management, there's different credentials for tier 1 management, and different credentials for tier 0 management. So if a user has a tier 2 credentials, right, then they're not going to be able to go into managing tier 1 servers, and they're not going to be able to go to tier 0 servers. So this is the way that we control the lateral movement within the company by setting up AD tiering. So let's put this together on our diagram, see how it fits. So here we're looking at it at the bottom. So in the environment, as I mentioned, we've got an on-ramp design here, redundant circuits. We've got dual on BGP coming in at the edge. We've got firewalls in place for network segmentation in the core switch position of the business, so that servers, wireless LAN, IoT, LAN, any kind of DMZs, all of those go into the firewall, so that we can not only detect what's going on in the environment, but we also have the right appliance in place in case we need to respond to a security event. We're not trying to put access lists on a core switch where that just doesn't work very well. It doesn't have the intel. We put these firewalls in the right place in the network. We put the security at the center, and now we've got the right intelligence to build better security policy. I mentioned here at the bottom, level up security. Instead of going source and destination IP and port, which is exactly how those are the information that's leveraged or exploited rather by bad actors, we move security off of that model, and security becomes about user IDs and app IDs and device IDs and zones and so forth. So with an intelligent firewall at the very core, then you can, on that firewall, you can create security policies that say this user and that app on this box. So getting these devices in the right positions is a lot of the battle here, making sure that the traffic is flowing through security appliances. Moving on to number 4. By the way, I forgot to mention, if you got any questions, please throw those in the chat. We'll be having a question and answer session immediately following the webinar here. So please feel free to put your questions over in the chat anytime. The 4th, I know you guys have probably never heard of endpoint detection and response, EDR, right? Actually, EDR is very popular nowadays, and for a good reason. In a situation where it's a company-owned device, right? This is something that the company has bought, whether it's a laptop, a server, a desktop, whatever. This is a cybersecurity focused agent that's installed on that appliance, which is geared specifically to detect events and allow a SOC engineer, an engineer to respond to a security event by shutting that machine down and so forth. We like SentinelOne here, OEDR managed services here, based on SentinelOne. This is basically does exactly what I was saying, monitors and notifies Security experts monitor the endpoints and respond in 24/7 as needed. And also there can be an active investigation. Let's say like with Log4j that happened recently. We know there's an exploit going on in the wild. Let's make sure that that's not at your business. So there's some we can leverage those different attacks that we know about and do a deep dive proactively on it. So let's put that in our diagram here. And that's going to be your remote users here, especially. We're going to be looking at putting an EDR agent on those remote users so we control those guys better. We're going to be looking at putting a EDR agent on local users as well as servers. And that's going to give us the right information from company-owned devices so that we can see what's going on. All of these logs will be fed into the SOC, as I mentioned, so it's managed. The more the SOC knows, the more it can correlate incidents, and the more the AI and the anomalous behavior can flag when something happens if it's anomalous. All right, number 5, and we are zipping right along. Top 6: managed SOC, immutable backups and air gap, hardening the network, hardening authentication, and EDR. What is going to be number 5? Number 5, SD-WAN and SASE. I think for a lot of these, for our clients that have a lot of remote sites, or at least several, and also have a global presence, and also have remote users that are not coming into the office, and also have cloud-based resources that these remote users are trying to go to. This is an area where it can really be transformative for the entire organization. Let me show you what I mean. In a traditional WAN, you have a branch office that normally is coming over an expensive WAN connection, normally MPLS or maybe a site-to-site connection, to a data center, wherever the data is. In addition, you have branch offices that are going out to the cloud for SaaS apps or cloud-based data centers. You have mobile users that are needing to access the cloud directly. However, that's not secured without putting a VPN in place and backhauling that traffic through a firewall at one of your locations and so forth. So instead of doing it this way, this is how we like Cato in this space, by the way. This is their diagram. We've had good success with them. The way it works is you put a Cato socket on site at each of your locations. So think of it as an SD-WAN appliance. What that's going to do is that's going to connect that location to Cato's backbone, to Cato's POP. That would be whether it's a headquarters site, a remote site, maybe it's a cloud data center and you need a vSocket, all of those. The idea here is that any traffic that's leaving a site in between where your users are and what the resource they're trying to get, it's going to cross this centralized security checkpoint from a remote branch or from a data center or from a cloud presence. It's going to pass through this single pass cloud engine where the traffic is going to then be secured as it needs to, from DLP to CASB, Zero Trust. All of that's taking place in a managed service. So you don't have to build all of that. Basically, you get this managed SD-WAN where it provides all of these security services. You can get rid of firewalls at remote sites. You can simplify and really scale down the complexity in your environments, because essentially your environment then becomes just a layer 2, right? We don't care if it's wired or we don't care if it's wireless. There's no resources at the remote site. Why not just go minimal on the network footprint there, send everything out of Cato's socket right out to Cato's cloud service, and that gives you a centralized place where you can manage all the security for all the users, because no matter where the user's coming from, no matter where they're going to be crossing this security scrub, if you will. So that's how the SD-WAN side works. It's an on-site SD-WAN appliance that's used to connect all sites, such as headquarters, data centers, remote office, and cloud POPs. Provides better redundancy, better security, and is cheaper. Now, this also includes the Secure Access Service Edge, and this is about replacing the VPN at your remote for your remote users that are out there. Instead of them giving them a VPN client, perhaps like AnyConnect or Global Protect or so forth, and having them VPN into your headquarters, it's going to provide a firewall as a service in the cloud. So they're going to connect to the closest Cato POP to them using the agent that you put on there. So it's a SASE connection into Cato's POP. And there, the same centralized security policy that you built for the SD-WAN is applied from a SASE perspective. So the user can then go from a remote device that is not owned by the company through a SASE connection into a cloud where the security is provided and it's scrubbed on their way to a cloud-based service. So that traffic is never brought into the business through a VPN and hairpin back out, and all the security is provided in a centralized place. Another big advantage is for our clients that have a larger global presence. We know that latency can be a real issue in some parts of the world. So Cato has a private global backbone. So the connection from the endpoint goes directly to their local POP that's closest to them, no matter where in the world it is, and then rides their global private backbone to wherever the resources is, either cloud-based or at another facility that's located normally here in the U.S. So this global private backbone, we've seen it drastically reduce the amount of latency in the traffic. So this is a big time upgrade, simplifies, and a big time upgrade. We think this is one of the biggest places that a lot of companies can really transform things and cut costs, if you will. Take that IT budget, and instead of paying for hardware on site like firewalls all over the place at every remote site, all the licensing that goes along with that, expensive MPLS circuits, expensive site-to-site circuits. Instead of doing that, you transform completely. So all you need is internet pipes, redundant internet connections out of each of your headquarter sites, remote sites, and so forth. Put the Cato sockets in place, send all of that traffic through the secure cloud, and that way everything is simplified, streamlined, and significantly cheaper, or at least maybe pay for itself by moving the budget around a little bit. All right, so let's look at what that looks like in our diagram. Here's, let me go back one, actually, if you remember, we had connections here, basically MPLS or site-to-site multiple connections. Instead of that, what we're now looking at is two sockets here with a basic internet connection coming out, just dumb internet, cheap, whatever bandwidth, right? Just so that it's redundant. These sockets are going to provide connectivity to the managed SD-WAN provider here, managed SD-WAN and SASE provider, so that all these network and security services are centrally located here. Wherever the traffic is going from a remote site, either to a local data center where your servers are, or directly out to the cloud, it's going to be scrubbed for security. In exactly the same way, SASE replaces a normal VPN into firewalls at either data center or headquarters, and hairpinning out. Now we can use firewall as a service with this SASE to come directly in to the cloud managed provider here, and straight over to the cloud here, and it be protected. So hopefully that makes sense. Again, throw some questions in the chat if you have any. Last but not least, number 6 in our priority is going to be periodic readiness assessments. Simple, hard work, right? Real world drills to verify competencies and accelerate your improvement. We're humans. We're better at things the 10th, 15th, 100th time. So the best thing you can do is to get out there and be daily and whatever the periodic schedule that you think is appropriate for the business. Do certain things. Get computers to do what they can do, and get real people to do what they need to do. For example, dailiness readiness assessments, security scans. These are Nessus type scans. We use Nessus quite a bit. We prefer Coda, actually. We think it's a little bit better in regards to how you handle the output of the security scan. And we like AutoMox in that it'll automatically update, do updates for us, rather than us constantly going and doing the security scans, finding the same failures, which is, the code needs upgrading. Now there's a maintenance to do that. We set up Coda, we set up AutoMox, and that kind of automates this so as much as the computer can do. But then we engage people for the things that the computer can't do. There's a big difference in a cybersecurity scan and a penetration test. This is an actual real person going and trying to penetrate into the environment. A blue team, which would be, the IT staff at the client, and a red team, which would be the white hat hackers, if you will, going in and actually breaking into the environment, looking for the specific weaknesses that your company has. What are the things that you can do to get you from being the slowest gazelle, if you will, to level up that security posture to where it actually is good enough is good enough. The other things that we recommend here, and lastly, as we finish up here, are failover tests. If we have redundancy in the network, like we mentioned, a redundant SD-WAN solution or an internet dual home BGP edge for your site, test those things. Do a real failover test to ensure that the high availability is working, and also simulate what a failure looks like. What does it look like when your firewalls fell over, or when a Cato socket fails over, or your DR solution or your service fell over? What does a normal failover look like? So it's not the first time you're seeing it in a real world, event. So go ahead and do those things that really make a difference. Go through the exercises, plan them, whether it's quarterly, twice a year or yearly, for these big things. Penetration tests, absolutely, as well as any failover tests for high availability in the network. Put that on our drawing. That's right here. Readiness assessments, security scans, remediations, red team, pen tests, and failover tests for things that are actually high availability built into the environment. So that is our top 6 priorities to make a full fence. First, managed NSOC, real eyes on real glass, looking at a portal that everybody has access to, AI-driven, anomaly-based. All the security threats are graded and given a security score, so that if all this alert cannon becomes actual information, it's scored so a person can step in and act. That's our first recommendation. Secondly, backups, immutable and air gap. Third, harden the network, harden authentication, get management out of band. Very simple solution that goes a long way. Number 4, EDR. We got to use this. We got to put cybersecurity agents on these endpoints, whether it's SentinelOne, CrowdStrike, or whatever. If the company owns the device, let's go ahead and throw an agent on it so we can get the intel off of it and then respond in case there's an event. Fifth, SD-WAN and SASE, as I mentioned, big time change, big time opportunity here to really transform larger environments, especially pull the security off of the network, firewalls, and so forth. Trade that money into a managed SD-WAN and SASE connection to centralize your security scrub as traffic goes from remote sites or remote users, especially either directly to cloud-based resources or local resources at your data centers. And then lastly, as I mentioned, readiness assessments. So that's pretty much it. I got a couple more things though. What's next? As I mentioned, good security requires a full fence. It just doesn't make any sense to build half a fence. So these are the 6 priorities that you need to be looking at in order to create a full fence. Now, if you're anything like me, which I know you guys are, you've been thinking as I've been going through this, well, where are we at? This is what he's saying, but where's my company at on this number 1, number 2? And that's what's next. I want to give you guys the 100-day challenge. Regardless of the size of your business and regardless of the budget, there are things that you can do to put yourself in a better security posture within 100 days. It normally looks like this when we're involved with these, and I think you folks will make this will make sense to you folks. First of all, take that 100 days, which is a little over 3 months, right? Use the first part. Where are you at currently? What do you envision for your future state? What is the roadmap to get you there? What does the future state look like if you did have a full fence? Or maybe you have a full fence, but what can you do to make it better? Current, future state. Put that down on paper. These are projects that we often do the way we normally do it. We come in, we do a current state, find out what's going on. We clearly diagram and document the future state, what it should look like. We give a very clear roadmap of how to get from point A to point B with findings and recommendations, prioritized, bill of materials and sales if needed, so that you know the cost and associated to get you from point A to B. That's the 100-day challenge. The first month, figure out, document it, make it make sense. Once you know, work through those things. And then that leaves you the other 2 months to implement things, the things in a prioritized fashion that makes sense, using common sense, right? What's the real world threats that are going on? What's our actual attack surface here? Recognizing that good enough is good enough. We are not trying to be first. We just don't want to be last. Well, how can we move us down that path? And lastly, don't break the bank, right? Leverage the things that you leverage, the existing investments that you currently have in place. It's not about particularly what vendor, keep it vendor agnostic. It's about making sure that if the device is kicking out logs, you're looking at them and responding to them. If you have something like Active Directory, you're setting up that tiering. If you have a network that does not have any east-west controls, it's about redesigning a little bit to get those things running through firewalls, as we've talked about. Get that security picked up a little bit. That's the 100-day challenge that I present to you guys as far as what's next. Now, last slide. This is the full diagram with all the things on it, as well as the what's next 100-day challenge. This would be a good time to take a screenshot for any of you that would like to have this as a kind of a reference guide in the future. And with that, I think we're going to go ahead and transition to our question and answer time. Again, thanks to everyone for spending a little bit of time with us here today. And let's go ahead and kick off some questions and answers. Let's make it dynamic. The more questions we have from you guys, the better we enjoy it. So please throw your questions in the chat and let's get to some of those questions and answers. Again, thank you.